Hello friends, let us see another example, another gate question. See how much lengthy, how much very bit lengthy, isn't it? So let us read the question first. A single unreamed pile 8 meter long, okay. RCC pile as shown in the figure, right? Weighing 20 kilonewtons. So weight of the is given 350 mm diameter and also 750 mm under rim diameter. Fine. Is installed within stiff saturated silty clay. They are given it is a clay material. 100 shears. That means indirectly they are given cohesion as 50 kilopascal. Adhesion factor 0.3. Applicable bearing capacity factor. So factor of safety is given as 9 to counteract the impact of soil swelling on structure constructed above. Okay, fine. Neglecting suction and the contribution of underrim to the adhesive shaft capacity. What would be the estimated tensile capacity? That means you have to find out what is the uplift capacity of the pipe. So how can we find out here? What is the uplift capacity? So if you are finding the uplift capacity, so what they're asking? Ultimate tensile capacity, round off to the nearest integer. They're asking us to find the nearest integer. So how can we proceed? Again, end bearing resistance plus frictional resistance plus sulfate of the pipe. That will be equal to the capacity. That will be equal to sulfate of the pipe plus end bearing resistance QB plus frictional resistance QS. That will be equal to what is the sulfate is given. Sulfate is given as 20 kilonewton plus what about the end bearing capacity? Yeah, let us imagine that you are trying to lift this pipe. If you are trying to lift this pile, will there be any contact at the bottom? The contact between the soil and the pile will break. So where you will get the contact? This is completely surrounded by the soil. So whatever this portion is not allowing, that means the under rimmed pile, the enlarged shape will not allow. That means there it will act in a normal pressure. So this is what the end bearing capacity. So whatever the area, it is not acting complete 350, not acting complete 750. So it is a, suppose if it is a enlarged dia and if it is the shaft diameter, so the resistance, normal resistance that will come in this halo in this area. So what about the area of this part? That is nothing but a pi by 4 into what about the enlarged shape? 0.75 square minus what about the shaft diameter? 0.35 square. So how many forces that are acting in the downward direction? Tensile capacity that will be equal to sulfate of the pile that is acting in downward direction 20 plus the normal force that is acting along the enlarged area. That is nothing but a pi by 4 into 0.75 square minus 0.35 square into what about the C value? 50 into what about the NC value? 9. This is what the bearing resistance. Then what about the surface frictional resistance? It will act throughout the shaft surface. So out of that we have to neglect this part. So total is 8 meter, 8 minus 0.4. So through how much length we will have the surface area? Surface frictional resistance 7.6. So what about the dia? Circumference length pi into 0.35 into what about the length? 7.6 into what about the adhesion factor? 0.3 into what about the frictional capacity? 50. Then if you solve this, you will get this value as around 300.86. So the answer will be, they're asking us to round off it to nearest integer. What is the nearest integer? That will be nothing but a 301 kilonewtons. So here one thing you will commit the mistake in this question, in this part. That means if you are trying to lift this pile in upward direction, you will have the bearing on the enlarged shape. That means along the bulb area, you will break contact at here. Only you will have the bearing along the or circumference of the enlarged shape. So most of the people will commit mistake. What they will write pi by 4 into 0.75 square, but that is wrong. Okay, if you are uplifting it, the contact between soil and the pile will break. So in your question, you have to see whether they are asking us the tensile capacity or they are asking the capacity of a pipe. Okay, thank you.